Hello guys, in today's video we are going to see binary search. So last time we have seen the linear search whose time complexity is n. But what if we want our time complexity to be less than n? And in that case we will use our binary search. In this binary search with the logic we are going to use, it will be like first of all let me use the pen. Yeah. Here we will initialize our first index as S and the last index as E, and we will compare our key element with the middle element. So our middle element will be nothing but, tell me what will be the index of the middle element. It will be S plus E by 2. Okay, and we will assign it to the mid integer. Now we will compare our key element with the middle element. Here you can see our key element is greater than middle element. Then we will go further, we will go to the next element, and now our next element, that is 27, will be S. Our S will be changed to here. Our E will be as it is, S will be changed to the mid plus 1. So this is nothing but mid plus 1. And then we will compare in this array only. We will compare the key element in this array only. Now you can see our first element of this array from 27, 34 and 42 is our key element. And if our key element is less than the middle element, if our key is 12, okay, if our key is 12, then what we will do, we will change our E to mid minus 1. Now our E will be mid minus 1. Okay, I will write here our key is mid minus 1. Then we will compare this in this array only. So you can see in 8, 10 and 12 our last indexed element is our key element. So now we will go to our program. So I have written the program for you. First we are taking the input array from the user. Here is our key will be given by the user, and we have to find out the index of that key, right? So we are defining a function with binary search, and it is taking the parameters array, the size of the array and the key element. Okay, and here above we are defining it. So the return type is the int, binary search with int array. This all the parameters will be given here. Then now first what we are doing, we are initializing of with s equals to 0 and e equals to n. Why we are taking e equals to n? We can take n minus 1 also. But what if the array elements can be odd number or even number? Okay, I mean the size of the array can be odd or even. So in that case it is better to take e equals to n only, not e equals to n minus 1. Then we are applying a while loop, and in this while loop the condition we are using is as less than equals to e. In the final, if our key element gets compared with the index that we want, it will be s equals to e at the last. We will see and our mid element, then we have seen our mid element. First I will format the document. Okay, now you can see our mid element will be s plus e by 2, and we will take conditions. Our if statement will be first array of the mid element. The middle element if is equals to key, then we will return the index of mid, that is s plus e by 2. And if else if our array middle element is less than key, then in that case we have seen here, if our middle element key element is less than array element middle element is less than key, then our s will be changed to mid plus 1. Just like here we are now changing our s to mid plus 1. Okay, and else what else, it will automatically get array if array element is greater than key, then our in that case e will be changed to mid minus 1. Just like here e equals to mid minus 1 when our key element gets less than mid element. Okay, and if there is no key element in the array that we want to find, in that case we will return minus 1. So this is our basic program. Let's save it. Let's run the code. Okay, I will define an array of 5. I will give an array of 5. Okay, let's give 13, 45, 67, 43, 68. Right. Uh, Now let's see the index of number 67. The key element here will be 67. As we can see, the index of the 67 is 2 and our output is also 2. So our program have been successfully run. Now I will see you in the next video.